Hi, welcome back to Discipleship Squared. Today, I want to introduce a new concept that we haven't talked about much. It's called irreducible complexity. And this is a concept that is often used to suggest that there is intelligent design in the universe and that many of the things that we see don't happen by chance. Instead, they are designed. And so we want to talk about that today. So, irreducible complexity. What in the world are we talking about? Well, let's talk about this and see if we can make some sense of it. This is the definition of irreducible complexity. It's a single system. It's composed of several interacting parts that contribute to the basic function, and where the removal of any one of the parts causes the system to effectively stop functioning. Now, that's from Professor Michael Behe, who is a noted uh, expert in intelligent design. Let me see if we can explain that using an example. This is a mousetrap, and a mousetrap could be considered an irreducibly complex type of instrument. Notice there are different parts of it. The spring here that is hooked to the uh, hold and the catch and the hammer and the platform. And if you notice, all of these things have to be there in order for a mousetrap to work. First of all, you got to have a platform for all these things to hook into. Otherwise, they'd all just be laying on the ground, and that wouldn't help at all. You have the hammer, and that's the part that goes over and smacks. It starts over here, and then it comes over here and smacks the mouse and kills it. But of course, that's also hooked to a spring. And what you do is you have this catch that's kind of like a trigger, and then you have this hold. So what we do is we pull that thing back, put this over here, and hook it up to this. And so all of these parts have to be there. If you don't have a spring, it's not going to snap into place. If you don't have a catch where you put the bait, it's not going to, why would a mouse come there if there's no catch there with bait in it? You got to be able to hold the spring in place. Otherwise, it would just stay over here and it wouldn't, the mouse could come in and get the bait and it wouldn't, get hit by the hammer. All of these things have to be in place for the mousetrap to work. If any one of them isn't there, it won't work. Now, there are several examples of things like this in the world today. One of the first ones that was ever shared or was ever really experimented with and talked about in terms of this irreducible complexity is the bacterial flagellum. Several bacteria have these little whip-like tails that they helps them swim about. And we just, for a long time we just looked at them through regular microscopes, but now with technology the way it is, we can look at them very close through electron micrographs. And when you do that, you find out that they here's a picture of just the motor part, the part that makes the actual flagellum spin around. And if you notice it got lots of different proteins here, and they all are interactive. Well, each one of these is a different type of protein, which would take a different type of gene in order to make that work. And what happens is you have to have all of them in place. Here's what it actually looks like, an artist's rendition of it. And notice it's got like, it has like a rotor and a stator, which is kind of like a little, electric motor. It has bearings in it. It has these different types of either protein or fat layers. Okay. And you have to have all of these in place. There's also a hook here that hooks onto the flagella itself and it makes it spin around. Now you have to have all of these in place in order for this thing to work. And if you look at it, I mean, it just looks like a little tiny nanomachine. Here's a more detailed piece of it. Like we said, it has different types of stuff. Like it has a rotor, just like a little motor would have. It has stators, which is kind of like the kinds of things that you would find in a little electric motor. It has these different layers of peptoglycan in it. And notice over here on the right, you can see all the different things This is a very intricate thing. It's like a tiny little nano machine. It's more complex than many of the things that we have been able to make at this particular size. Now, if you want to know this, whoops, let me get back here. Well, I didn't want to show that. Let me stop here. There we go. The point is that you have this machine and it's very, very complex. You would have to have several mutations. I mean, lots of mutations in order to get this to actually work all at once. And if any one piece isn't there, like if the rotor isn't there, it's not going to spin. If the stators aren't there to make connections with these proteins in here, that's not going to work. There are, I think, 20 different proteins that have to be here all at the same time. Otherwise, it has no survival value. And remember, according to evolutionists, in order for something to be able to be passed on to a new generation, it has to have some type of survival value. But this has to all be there, or there's no survival. And you can see here's an artist's rendition of how this thing actually is. It's a pretty complex piece of machinery. Well, what are we trying to say? Well, the point is this can't really happen by chance. Evolution at its very nature says it has to have survival value. And the evidence right now says that you might be able to get one mutation or two mutation to happen by chance at a particular time, but to have 15 or 20 happen all at once, that never has been that just doesn't occur. And so it's irreducibly complex. It's not going to happen by chance. It looks like it's been designed by an intellect. If you see something that looks like a little motor, you don't anticipate or think about the fact that it's like oh, this just happened by chance. It looks like it was designed by an intellect. Here's another example. This is called the Bombardier Beetle. Sometimes he's nicknamed the arsenal insect. Now, the Bombardier Beetle, he gets eaten by predators, especially, like this one here. If you got a mean old beetle eater comes up behind, the Bombardier Beetle, the beetle has a little trick up his sleeve. Actually, it's up in his hind end. What he does is he mixes some gas together and it shoots out at about 212 or 214 degrees Fahrenheit. And it literally hits the toad or the frog or whatever it happens to be in the face, and he will run away and never attack a Bombardier Beetle again. Now, how does this beetle do this? Well, here's a diagram of the Bombardier Beetle, and this is how it basically works. The beetle has hydrogen peroxide in it that's produced by some glands. It also has glands that produce hydroquinone. There's a sphincter muscle here, which kind of controls how these things are shot or put into this. And then there's like a little explosion chamber where all the stuff can actually mix together. And when it mixes together, then it shoots out this really, really hot gas at about 212 degrees. Now, the point is that you have to have all of these particular pieces in place for this to work. Here's an example of a beetle. Notice not only does he have that stuff inside that he can squirt, but he has this little like, it looks like a little gun almost that he can point in any direction. Here he's pointed almost between his legs. And then the next picture, here's somebody sitting on his head there on his front post. So now he's pointing that thing in the other direction. And believe me, after this picture was taken, this person moved his finger very, very quickly because that thing is very, very hot. Now imagine this. How could this happen according to evolution? Now, evolutionist says that you have to have survival value in order to pass, or in order to survive and pass on your things to the offspring. Well, if let's just say that the beetle, he ended up making some hydroquinone. Well, that's great, but if a beetle had a mutation that was like that, it wouldn't give him any survival value, because if you just have hydroquinone by itself, it doesn't react with anything. So these beetle eaters would just come up and eat this guy and chow him. But let's say, okay, well, let's say maybe he got hydrogen peroxide glands as well as the hydroquinone. So now what he can do is he can actually mix them. But if he didn't have this sphincter muscle, the control and these little explosion chamber, what would happen is it would react right in here and it would blow the beetles up. So generation after generation, you'd have these beetles, boom, 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 blowing themselves up because they didn't have all the parts. But let's say just by some miraculous chance that they got this hydroquinone gland and this hydrogen peroxide gland, and they got a sphincter muscle, and then they got an explosion chamber. So now what happens is they can actually mix it, and it comes through that muscle, and it comes out the back end, and that's great. And so this would help it, but it also has to have a neural network in order to control this. You can imagine if Beetle Bailey is dating his girlfriend Joanne, and she comes up behind him and says, "Hi, Beetle, how you doing?" and puts her hands on him, and boom, she gets shot in the face with this because he doesn't know when or how to shoot it. He doesn't have the neural network to do it, and he doesn't have maybe the right thing to aim it. In other words, there are about 12 or 14 things that have to be here. They all have to be present. If they aren't present, then what will happen is it won't work. They all have to be present at one time. So he's irreducibly complex. All the parts are needed to work at once. So he's irreducibly complex. That shouts like design. I mean, think about this for a second. How in the world could a animal like this, a beetle, get and inherit all these parts all at once and use them correctly? I mean, it strains the mind to think about that. And according to the evidence, we don't see lots of mutations happening all at once. We see maybe one or two. And yet, in this case, you'd have to have 8 or 10 or 12 all at once in order for that to happen. And the evidence doesn't support that. Now, you can believe that things can happen by chance like this, but there's no evidence to suggest that it can. Okay, not that many things. It's irreducibly complex. Another system is the eye. I don't know if you ever thought about it before, but your eye is a wonderful, very complex machine. In fact, it has about 40 different subsystems that they're all working together in harmony with each other. I mean, think about it. You have a pupil that dilates. So depending on how much light you get, it'll dilate more or less to allow a certain amount of light in. It has, the vitreous humor or stuff inside of it. And then on the back end of it, it has like a retina. So you have to have it. That's where the image focuses it. You have a lens here that gets thicker or thinner so that you can actually focus it as well. Plus, there's a optic nerve that has to go hook here, and then it hooks to your brain. And of course, on either end of those have to have certain proteins. So you have about 40 different subsystems all together to work in order to have an eye. Logically, they all have to appear instantly together, or we would all be blind. Now, can that happen by chance? Well, no. I mean, any reasonable person would look at all of these different things and see, if you didn't have the lens, or if you didn't have the vitreous humor in the inside, or if you didn't have the optic nerve, or maybe the retina was too close or too far, or there wasn't. If you have any one of those things missing, then the eye doesn't work. And so it has no survival value. And not only this, but evolutionists say this didn't happen just once, but it happened in 5 different families. 5 different groups of critters. Now that strains the imagination for sure. To say that this happened once is already like, it's like we can't believe that. But to say it happened in 5 different groups, that the eye had to occur 5 different times that it could do that, well, again, this screams design, not chance. So again, the eye is irreducibly complex. And irreducibly complex items really suggest that things didn't happen by chance. It suggests that they were designed. And design screams for a creator or an intellect that did all of this behind it. So, there's 3 examples of irreducible complexity that are really, really important, and I think very, very convincing to a lot of people that there actually is design in nature, and there was something or someone behind that. And of course, the Bible suggests that 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 person is the creator.